Thank you, Phil. Thank you, everyone. Last talk. No pressure. I was looking at my slides last night, just refreshing a few things, and I looked at the title, and I suddenly realized cross-compilation is a cross-compiler, is a compiler capable of creating executable code for a platform. It's when you cross-compile, so you compile on, say, Linux for another operating system. I suddenly realized that's not what I'm talking about. I got the title wrong. So I apologize if anyone wants to leave now. What I probably should have said is equivalence in cross-platform compiler warnings. So what I'm talking about is when you have a code base that you compile for different operating systems with different compilers, how do you make sure that code's going to work across everything you compile on? So we have a large code base. I say legacy code base, but I mean everyone's got a legacy code base. I remember reading a definition of legacy code once as code you wrote yesterday. We use it to build a whole bunch of different products. We build for both Windows and Linux. There are some reasons for that, partly historical, partly technical. How do you make sure that code that compiles for one platform compiles for the other? There's a constant problem we have is you make a change to the code, it compiles fine on your machine, you create a pull request, it all looks good, it goes to the build system, and then one of the other builds fails because you made a change that doesn't work on that build system. So how do you use the compiler to try and prevent this? So we, as I said, we build for Windows and for Linux. We are using GCC on Linux and MSVC on Windows. I do apologize for the LLVM fans in the room. It's not that I don't want to use it. We don't use it, and I don't have any experience in it, but I do have my homework. So when I get back, I will be going to try it out. So yeah, at the moment, we use this set of warnings across the compilers. So in Windows, you can set level 4, which is basically, there are 4 levels in Windows, level 1 being the most basic, level 4 being the most stringent, if you like. And then we also turn on treat warnings as errors. I'm sure there's probably a debate somewhere about this, whether you want to treat warnings as errors or not. The simple fact is, if you treat warnings as errors, you can't ignore them. Now, you also then find yourself sometimes going and sticking a pragma around something to turn off a warning for a piece of code you can't fix for that particular warning, but that's a balance you kind of have to make up for yourself. For our particular situation, that's what we do. I did come across quite recently, so I should mention, we're still using Visual Studio 2013. I can't remember the MSVC version in that. And GCC 4.8, we're still on C++ 11. For the purpose of the talk, the examples I'm using the most recent compilers, just to show that the issues still exist. But there are some things in the most recent compilers that aren't supported. One of which, I read a blog post quite recently, this permissive switch, which apparently turns off some of the functionality in MSVC that isn't supported on other operating systems. So it's possible that may help in this situation, but it's only supported in Visual Studio 2017. GCC on Linux. So Windows has this model where you have these different levels. GCC has this alternate model where they have the WAll, which is all the warnings from some previous version. I was actually trying to figure out where WAL was first added. I couldn't figure it out. So there is some set of warnings they used to have in a previous version. They have not added to that set. They then defined extra. Was one I hadn't actually seen before was shadow. That's actually mentioned in this blog post down the bottom. Conversion is another one we use, warning for implicit conversions. I'll go into that in a little bit more detail later. And then we turn on treat warnings as errors. There's also pedantic, which we don't use at the moment. I want to go and have a play with. And then there was a blog post quite recently naming some of them like shadow. I saw Jason was using that earlier. Which may be of interest. Now, that's the basic set of Windows warnings we use. I'm not going to go into every single warning we do use in Windows, because there's quite a lot of them. There's probably a whole separate talk in that. So just a quick overview of these. This is what we use. These are the warnings we disable. So in warning level 4, these are turned on normally, and we turn them off because they're kind of pointless. So for instance, C4351, which is what's the 5th one down, new behavior elements of array will be default initialized. It's just Microsoft saying, oh yeah, now we do default initialization. This is different from what we previously used to do. So it's not really a warning, it's just kind of a note. The problem is if you turn on warnings as errors, that becomes an error, which is a bit silly. So we disable it. I'm not going to go into all of these, but as I said, the slides will be available. Feel free to go and have a look through it yourself. But this is a good set we've found. And then on the same, there's a bunch of additional flags we enable. These aren't enabled in warning level 4, but we find them useful. So for instance, C4263, it's about 5 from the bottom there. Derived class, default constructor was implicitly defined as deleted because a place class, oh, have I got the wrong? No, sorry, it's the next one down. I've made a copy-paste error there. C4263, member function does not override any base class virtual member function. So this warning, it basically says if you've got a base class and you've got a subclass which has a function with the same name as the base class, but the parameters are different, it warns you. Because it may be that you intended to make that an override and you kind of forgot, and then over time, one of the others has changed. So it's not technically an error, but they're just kind of saying, hey, this looks a little funny. And I turned on that quite recently, and we did find some actual warnings, some actual bugs with that one. So we compile for Windows and Linux. So obviously, apart from the whole proprietary versus open source business, what's the biggest difference between Windows and Linux? Exceptions. Possibly? Sorry? GCC. Well, I suppose so, yeah. Sorry? POSIX? Well, yeah, inherent in being Linux. So to me, one of the most fundamental differences is case sensitivity in the file names. It's a very different philosophical stance, if you like. And also, Windows really doesn't care whether you use a / or a backslash. Now, it's a relatively minor point, but it does have implications. So I'm using Compiler Explorer. These are actually screenshots. I didn't want to risk trying to get internet access during my talk. I've hidden the assembler down the bottom there. I'm sure Mr. Godbot would be furious if he saw these slides, but they're not particularly interesting for what I'm talking about. But you can see here, I've deliberately badly formed that hash include, boost format with a backslash and a capital F. And Windows is perfectly happy with that because it's a case-insensitive file system. Now, you can actually see down here, it says it compiled correctly. The stuff you can see there is actually a bug in Compiler Explorer. It's accidentally printing out some of the data it gets from Wine, which is what it used to run MSVC. I went to raise a bug on GitHub, and it turned out that Mr. Godbot had already raised the bug. They just haven't got around to fixing it there. So really just concentrate on the bit at the bottom there. It did compile correctly. And as you can see here, I'm using the latest version of the compiler. The /ehsc just turns on exceptions. If you don't do that, you generate a whole pile of warnings from the headers. It gets confused. And then I've turned on warning level 4 and warnings as errors. Same code, GCC. Doesn't like it, obviously. And in fact, when I was giving this to a colleague, this talk to a colleague of mine, he pointed out that you could even end up loading the wrong file in Linux. Not from the backslash, obviously, but from the case sensitivity. So it's an obvious problem, but you can't catch this in the Windows compiler. It just doesn't understand the concept. I actually mean to raise this. Microsoft are obviously doing a lot of effort at the moment putting into Visual Studio 2017 and Visual Studio Code to make them capable of compiling just about anything you can think of. I actually want to create this as an improvement. They may already have it, but I haven't checked, because it's the kind of thing that gets in the way of you doing cross-platform compilation. So I learned C++ something like 1992. I don't remember the exact day. It was slightly weird. When I went to university, we actually learned Pascal in the first year. That was the university official teaching language. It's a really good teaching. It was designed as a teaching language. But anyway, it's pretty old now. And then the second year, the university decided to change their teaching language to C and C++. But in those wonderful piece of logic, they said, you've already done the first year programming course, therefore you must know the university programming language, which has just changed. So we had to teach ourselves C and C++ in the second year to keep up with the lecturers. Happy days. Anyway, I learned C++ a long time ago. Back then it really was kind of C with classes. I mean, even the STL was ratified in 98, I think. It didn't really exist back in those days. And there was a much longer time between those kind of things turning up in compilers. So I don't remember really seeing the STL until about 2003. So there's been a lot of improvements in C++ along the way. Some of the things I really most enjoy about the improvements to C++ are those aspects of the language which allow you to, to fix problems that previously would have gone unnoticed. So the obvious one is enum class, which kind of filled that hole where you could have an enum, but it wasn't type checked. So you could end up making mistakes in your enums which didn't show up in the compiler, but then they created errors later on. So when we first started playing with C++11, I started going through our code base and fixing up some enums just to see what happened. And this is an extremely simple piece of our code. The original code's much longer. And you can see in Visual Studio, this compiles fine. There's nothing wrong with it. But there is a bug. And the bug is, we've got this enum, e-coordinate type, and then an explicit constructor, which takes one of these coordinate type classes, and then a double. And the compiler is quite happily saying, oh, that enum, that's actually an int. So that's perfectly acceptable to pass that in as a double. This was a bug in our code base. And of course, once you change that to an enum class, it spits out an error. It says, well, hang on a minute, I can't use that. So we fixed this. It's one of those funny bugs. I should have said I work for Navico. For those of you who live in New Zealand, it's what became of the marine part of Navman when they shut down in about, when they got split up in about 2007. So we make stuff for boats, autopilots, chart plotters, radars, sonars, those kind of things. And this is one of those funny bugs. It's obviously a bug in the code. I don't know what impact that may have had on the product, but I did have this weird mental picture of a boat with an autopilot going around in circles, trying to get to an altitude on the sea. I'm pretty sure that didn't happen, but you never know. So you can see same code in GCC, except GCC's given us an error. It's saying that coordinate I set up there isn't used, which is absolutely correct. This is just demo code. But that didn't get spotted by Visual Studio, which is kind of strange. Visual Studio has a warning, which is turned on in level 4, C4101, unreferenced local variable. It just doesn't seem to spot this one. I had a sort of poke around. As far as I can tell, Visual Studio says, oh, you've got a variable here, and we've initialized it therefore it's being used. Whereas GCC says you've got a variable and it's been initialized, but you never did anything with it, so it's not being used. Here's a really good example of how compilers have even the same warning, but they're not equivalent. So what else can we do with enum class? Oh, sorry. So yes, when you add the enum class to GCC, it then gets the same error, or a similar error to what we had in Visual Studio. So what else can we do with enum class? Well, the other thing you can do is when you have a switch statement with an enum in it, when you have a switch statement that's switching on an enum, you know the scope of the enum, the enum class. So you can identify if you've missed out parts from the switch statement. So firstly, looking at GCC here, it's a very simple setup. I've got 3 states in my enum class, and I'm only addressing 2 of them. And it's come back and said, well, you missed one there. And that warning is actually included in WAll, I think. So it's quite useful if you've got a switch statement using an enum class, and then you add something to the enum class, the compiler picks that up. Whereas previously it wouldn't have done if you were just using an enum, because it's an int and it doesn't know what the scope of that int is. And you can fix this easy enough by adding that state in there. Or you can use a default. It effectively says, well, you've got a couple of states here, and then we'll just cover everything at the bottom. And there are certain situations where that's really good. For instance, if you had an enum class that represented all the key codes you could possibly receive, you probably don't want to list them all out. The default's perfectly reasonable. So what does MSVC do? Nothing. I was perfectly happy with that code. It turns out there is a compiler warning for this, C4062. It's off by default. It's not included in W4 in Visual Studio. I don't know why. I don't like to second guess people when I wasn't in the room and the decision was made. There may be a very good reason for this. But for what we're trying to achieve here, it's kind of funny. So this is one of the ones I listed in that slide at the start. This is one of the ones we turn on because it's turned off by default. So once you add that in specifically on the line there, it then gets the same kind of problem. So Visual Studio, unlike GCC, when you say, I want to turn on all warnings in Visual Studio, it does turn them all on. So what happens if we turn them all on? Is that a bad thing? The problem with Visual Studio, or MSVC should I say, is when you turn on all warnings, it goes a bit nuts. It basically starts warning you about its own headers. I mean, the path there is a little odd because this is Compiler Explorer, but you can see this is crazy. There's no point doing this. It doesn't tell you anything useful. So don't use WAL in Visual Studio unless you're not actually using any outside headers at all. If you have a completely self-contained code base, maybe you get away with it. So again, in Visual Studio, with that warning turned on, you can fix the problem by adding the other state or adding a default. I don't know why the intending's gone wrong there. That's strange. So what was the other compiler flag I mentioned about GCC was conversion. Now there's the official explanation from GCC. It is an optional flag you can turn on. It basically warns you if you're doing a conversion between 2 types and there is some sort of loss of value, loss of information, should I say. So you can see this. This is another piece of code I just pulled out of our code base. It doesn't really matter what it means. It was just an example where you turn on warnings. So you turn on a conversion warning in GCC, and it flags this. And it's basically saying, well, the range is a float, and range limit is a float. Input amplitude is an int. But we want to change it to a float to complete this calculation. But if you're using the standard IEEE implementation of float, which is what they are, float has less precision than int. An int is 32 bits, normally on a 32-bit system, so it can have 32 bits of precision. A float can only have 24 bits of precision. So there is a possibility here of losing information from that int. Now, it might be quite a small chance. You might not be particularly worried about this situation, but it is telling you that's going to happen. Or there is a possibility of that happening. And you see this a lot. Sometimes it's unavoidable. You get functions like the functions to return the size of a screen, and they return a 32-bit integer. I don't know if they're planning for the future when screens get to be really big, but most of the time you could put that into a word, and a word will translate to a float quite happily. So you can fix this with a static cast. It's basically saying, look, I don't care, it's actually an int, I'm going to cast it to a float, and then the problem goes away. But it's a bit clunky. I was lucky enough to go to C++ 2017, a month ago now, and I saw Kate Gregory's talk, 10 core guidelines you need to start using now, which is about the C++ core guidelines. I'd heard of them, but I hadn't really sort of gone and read them, to be honest. They're not really readable in the sense you sit down and read them in a single sitting. But one of the things she talked about was this: avoid lossy arithmetic conversions. I've cut out the examples here just so I can fit it on a slide. But in the second paragraph, the note says the guideline support library offers a narrow cast operation for specifying that narrowing is acceptable and a narrow that throws an exception. What's the guideline support library? I hadn't heard of this before. The guideline support library, GSL, is a library written alongside the C++ core guidelines to provide functions that help you with the guidelines. There's an implementation on GitHub written by Microsoft. I mean, it's written by Microsoft, but I mean, it's open source. That one requires C++ 14 support. There's a second one I found on GitHub, GSL Lite, which actually is backwards compatible to C++ 98. There may well be newer versions of this, other versions of this I haven't seen yet. There's no particular reason why there couldn't be hundreds of them. But basically, it's a support library for the core guidelines. So what can we do with this narrow? Well, basically, it is the equivalent of doing a static cast, except it tells you the intention is to narrow that. So I know I'm casting an int to a float, but that's okay, that's what I intended to do. So it tells the person who comes after you to this code what you intended to do. You didn't just forget what you were doing, you intended to narrow that cast. And in this situation, as I said, where you were dealing with something like a screen resolution, there's really no issue with that. There's also the narrow one. So it basically does the same thing, except if the int won't fit in the float, it throws an exception. And we should all be thinking about exceptions. So if you want to actually make sure you're not making a mistake here, you can do that as well. So what does, this is all GCC. So what does Microsoft do in this situation? Nothing. It doesn't care. Hasn't noticed. Which is odd. Oh, and to prove the point, I've actually turned on wall here. I don't have any headers, so there's nothing to screw up. So even if you turn on all Microsoft warnings, it doesn't tell you about this one. Now, Microsoft does have an equivalent warning, C4244, conversion from type 1 to type 2, possible loss of data. And this is actually the example from the MSDN documentation. And as you can see, it picks up that that is an error. But it doesn't pick it up on the previous example. And I think, I obviously haven't seen the source code, I think what they're doing is they're only checking this on the assignment operator. So if it's happening within the right-hand side of the function, they're ignoring it. They're only caring when that value carries through to the left-hand side of the function. So again, a different interpretation of the same warning means this code works fine in Visual Studio and then gets warned on in GCC. As I mentioned, I'm using the latest versions of Visual Studio and GCC compilers here, so these are issues that exist today. And I do mean to raise these with Microsoft, because I would like to think they want to make it easier to write cross-platform code. But it seems odd that they've got these different interpretations of warnings. I always kind of assume that these were specified somewhere. So I went and had a look at the C++ standard. There's only 4 mentions of warnings in the whole standard. I didn't read the whole thing, I just did a word search. I asked about this on the C++ Slack channel, actually, and somebody came back, and I've quoted them, I'm afraid I can't remember who it was. They were saying that the key phrase is diagnostic required. They don't refer to warnings in the standard. They refer to this thing called diagnostic required, which is basically their way of saying the compiler should be doing some stuff here to tell the user what's going on. But the final quote that I got, the only thing it requires from compilers is to diagnose when a program is ill-formed. If you grew up with BASIC, you'll remember syntax error. It's basically saying, I don't understand this. So a lot of the compiler warnings that have been added in have been done by the compiler writers, not the standard. So is that it? Are we just kind of stuck with what we've got today? Well, I listened to CPPcast, and I think this was in June, an episode. They had Patrice Roy on, who's pretty well known. July. So it does. It's clever. He's been on the standards committee since 2014, and about 30 minutes into the podcast, he says, people have even talked about standardizing in some warning messages. It's something that's floating around. There's nothing official there. We're just talking now. But it is interesting to hear that they're kind of considering this concept. So the other point that I found really interesting about this is that if you go back to the core guidelines, that third piece talks about enforcement. A good analyzer can detect all narrowing conversions. However, flagging all narrowing conversions will lead to a lot of false positives. Suggestions. Flag all floating point to integer conversions, maybe only float, char, and double it. Here be dragons. And if you actually look in the standards, in the core guidelines, this phrase is used quite a bit. And obviously someone's used it as a sort of little to-do marker, saying we need to revisit this stuff. So I like to think that, I'm second guessing here, but I like to think that their intention is to nail this stuff down a bit more and then provide these to compiler writers as a sort of guideline for warnings, to make the warnings a little bit more standardized. Because right now, we don't really have standardization of warnings. There are a lot of the same warnings between compilers, but they're not standardized. They're interpreted differently. Some of them are turned off by default. Some of them are turned on. It's a bit of a kind of come as you are. So unfortunately, true platform compiler equivalence is not really possible yet. Compilers have different warnings. Difference exists between the compiler warning implementations, which means you can't rely on those warnings picking up the same code. Okay, this was a short talk, by the way. Any questions? Yeah.
Will using a single compiler fix your problem?
Some of them. I mean, the first issue I pointed out with Windows and Linux having a different interpretation of file names, that's not a compiler problem. That's actually a platform problem. So you kind of want the compiler to be able to warn you about that situation, even if you're using a different compiler. But yes, I mean, theoretically, if you were able to use one compiler across all of those different platforms, that would certainly help because the implementation of the warnings would be the same.
But that wouldn't help if you're running a library and you've got your customers or your users, something like that. You wouldn't be able to control that.
Well, you could just tell them. Only use one compiler. Sorry, the question was, forgetting to repeat the questions. The question was, or the point was that you can't specify the compiler if you're writing a library and you're providing it to customers as source. Anyone else? Yep. Sorry, say that again?
Using list initialization to force the compiler to complain about narrowing?
So the question is, would using list initialization be a way of forcing the compiler to warn you about narrowing? Possibly. I haven't done exhaustive testing on this, and there's always the danger that the compiler writers have got a different interpretation of that. But yeah, it's entirely possible. This hasn't been an exhaustive search of every single. This was really just issues that came up in our code base as I tried to raise the warning levels on the compilers. At the back there.
Have you got any thoughts about somehow baselining your legacy code base when you decide to turn the switch on and you've got 5,000 warnings and you just want to get fewer?
So the question is, any thoughts about baselining or code base? So when you turn on a new warning and you get 5,000 warnings, you just want to know when you're getting lower. I mean, we turn on warnings as errors on everything. You don't have to do that. You can actually turn on specific warnings as errors. So one way to do that might be to identify the warnings that you want applied without any exception whatsoever and make those warnings as errors. And then pick warnings that you'd like to improve, just make those warnings, and then have some sort of system that reports the number of warnings through your build system or something like that. So you can hopefully get a downward trail and possibly even make it part of your pull request to say, well, you've raised the number of warnings in the system, that's not approved. I don't know, it sounds like a good idea, but yeah, it is quite fiddly to be able to turn on the warnings one at a time, although I think there's a way of saying warnings as errors except for these warnings, but I'm not sure if that's applied equivalently across all the different compilers.
Have you looked at any of the numerous code checking tools like CPP check and a couple of the other names? There's a lot out there that will do this kind of error checking and take over the compilers and they can.
Yeah, so the question was, have we looked into static analysis tools? The only one I've got experience of is ReSharper++, because I won a copy from CPPcast. Thanks for that. Which is really good, and it does pick up on a whole bunch of stuff that, especially because we're still using Visual Studio 2013, those warnings don't exist until later. But obviously the compiler, whatever it is they've got built in, is much better at spotting those issues. So yeah, those can definitely help. But it goes back to that argument with turning on warnings as errors. You want to enforce that. I mean, it would be really nice. There was some discussion on the CPP Slack channel quite recently about the idea of when you do a pull request and it comes up in Gerrit or Bitbucket or whatever you're using, it would actually do some sort of static analysis on the pull request and show you how good the code is. I haven't seen that system used anywhere. I think somebody said they were using it in-house, but it was obviously a proprietary thing. They hadn't opened it up, but there are definite possibilities with that. If you can do a pull request and people can look at the code change and then see the analysis of the code change, that would be another way of improving your code quality. Yep.
Do you use any sort of continuous integration system? we have something in our in-house tools that whenever you commit something or create a pull request, it automatically compiles for all the target platforms and for static analysis and unit tests. So basically you can't ignore that thing that you can't just miss something that breaks on some certain platform because it immediately shows up.
Yeah, that is something we're working on at the moment. In fact, there was a conference in Auckland quite recently called DevOps Days, and my manager did a talk there about how we're introducing continuous integration, because we are an embedded company. We make embedded products. So we do actually, when I talk about compiling for Linux, we are actually cross-compiling for Linux. This wasn't what that talk was about. But yeah, so we have a build system. When you create a pull request, it goes off and does a build for it. The biggest problem we've had is that the builds just take too long for us. And we've had to do quite a lot of work into, so we've now adopted Ccache on our Linux builds, which helps a lot. There's sort of an equivalent thing called, I think, CL cache for Windows. We haven't managed to get that working properly yet, so we're still having a look at it. I know there's a Facebook tool that was presented at CPPCon, I can't remember the name of it, that does some similar stuff. So yeah, definitely a CI build is an important part of improving the quality of your code base.
In my experience, it vastly boosts productivity.
Absolutely.
We're out of time now.
Okay. One more, or is that
Yeah, one last one.
Nick?
I was just going to ask if there was any particular way that you went about finding new warnings to turn on. Like, would you turn on wall on Visual Studio, for instance, and then go back through and look if there was interesting ones?
Yeah, so the question is, how do you find new compiler warnings to turn on? Yeah, turning on wall in Visual Studio is one way of doing it. GCC doesn't have a way of turning on all the warnings. It's just, I found a discussion about it on Stack Overflow. It's just seen as pointless, but partly for the same reason that Clang has. If you turn on all of the warnings, some of them are contradictory and it doesn't make any sense. So, but certainly in Visual Studio, turning on wall will show you all of the warnings. You can then kind of try and figure out what they were, but as you saw from the slide earlier, there's so much stuff in there, it's almost unusable. But it's certainly a way to find that warnings exist. The other thing is, I mean, it's blog posts, discussions, ask Jason. Okay, I think that's time's up. Thank you.